what lies ahead when tomorrow comes. Every single night as we settle down to sleep, this precise thought drifts into our minds. It represents perhaps the absolute greatest conundrum facing all of humanity. We simply cannot prevent ourselves from wondering about what our destinies hold, and feeling anxious about the unpredictable events that might be waiting in the days to come. Every person alive harbours a desire to peek just a few days or several years forward into their destiny, to discover exactly what their reality will look like. Will you be experiencing the absolute existence of your dreams, or is an incredibly agonizing event waiting to take place in your path? Consider what the absolute worst outcome could be for you personally. Mortality. Passing away will eventually claim every single one of us, without exception. Not a single person throughout documented human history has ever found a way to outsmart mortality, and regardless of how aggressively we attempt to evade it or push it off, passing away will come to every one of us when our time arrives, far into the future, billions of years from this moment, when the sun expands and consumes our planet completely, or if a devastating cosmic occurrence, like a massive space rock collision, takes place. Our entire reality will break apart into microscopic particles. These remnant pieces will scatter carelessly across the unfathomable wilderness of the cosmos, drifting without direction through the grand cosmic tapestry. We will ultimately transform back into the exact same atomic components that originally gave us life. In essence, we will return entirely to a baseline condition of non-being. Even so, the grand cosmos will carry on with its unstoppable journey forward. The solar system's central star will still ascend and decline across an uncountable number of separate worlds. The planetary periods will alter right on schedule, and the oceanic waters will consistently rise and fall back. Brand new stars will pull themselves together, and fresh worlds will take shape, keeping up the constantly transforming network of living things. The overarching universe will persistently stretch out and modify itself as the eons tick by. All occurrences will happen precisely the way they have played out in earlier eras, with the sole variation being that this time around, your physical presence has altered its state. This shift leaves you completely oblivious to the massive transition. Because of this, you will have no capacity to detect the adjustments occurring all around your position. Therefore, whenever you raise your eyes to observe the midnight sky, keep in mind that the glittering points above could very well be made of the exact same material that once formed vital pieces of a living creature. The void of space is a literal ocean of endless opportunities. It represents a territory where even the things that seem totally impossible can cross over into reality, and there are specific instances where strange phenomena happen that defy easy explanations within a universe ruled by rigid numeric equations. Simply look directly at the night sky stretching over your head. Why is it that the celestial objects, which are completely controlled by these unyielding numeric laws, scatter themselves in a condition of absolute lawlessness? Why do we never see stars replicating structural arrangements across the universe? Could this completely disorganized layout actually be a grand message from the cosmos? A hidden signal that has been missed and has dodged the awareness of human beings throughout the generations? Perhaps it is a meticulously put together letter from a non-human intellect. Furthermore, think about the endless billions of glittering objects that mark the boundless universe. How can it be real that we find ourselves completely enveloped by an infinite quantity of glowing, light-producing stars, and yet the overhead sky remains totally black? If the grand universe is truly without an end in time and boundless in space, and if the stars are spread out evenly across the enormous emptiness of space, then no matter what path we point our eyes toward, we ought to spot a star. The light radiating from these celestial bodies, regardless of how incredibly far away they are, would eventually travel all the way to our home world. Since the very dawn of human history, every single person who possesses an inquiring spirit has pondered these exact dilemmas at least once in their life. Today, with the rapid progress and widespread access to cutting-edge astronomical instruments at our disposal, we find ourselves standing closer than we have ever been to untangling the secrets that have bypassed us for centuries. It is finally the moment to strip away the protective layers of mystery that cloud our perception of the wide cosmos, allowing us to shine a bright light directly on these mesmerizing riddles of the universe. Examine this specific photograph with great attention. Right here is Eugene Cernan, captured in this frame, honouring the national banner of the United States. He was the very last human being from the historic Apollo program to press his boots into the dusty terrain of the moon. Yet, if you look much closer at the image, you will likely detect a detail that is incredibly strange. There is not a solitary star visible anywhere in the background space. As a matter of fact, every single snapshot captured on the lunar surface throughout the legendary Apollo expeditions displays an overhead sky completely empty of any stars whatsoever. This happens despite the reality that the cosmos is absolutely overflowing with an uncountable number of flashing astronomical bodies. Even the Apollo spacefarers themselves later verified that they were completely unable to make out a single star in the overhead lunar sky. This confusing situation has triggered all varieties of arguments and secret plots over the decades, with certain individuals going so far as to point to the complete lack of stars as definitive proof that the entire lunar landing was nothing more than a staged trick. However, the actual explanation for this spatial puzzle goes significantly deeper than any simple cover-up theory. In truth, the ultimate answer to this celestial riddle guides us back once again to a monumental astronomical reality, the Big Bang. Why exactly is the void of space so profoundly dark? The core concept behind this particular inquiry was originally brought forward by the astronomer Johannes Kepler all the way back in the year 1610. Our singular Milky Way galaxy by itself contains anywhere from 100 billion up to 400 billion individual stars, and the portion of the universe we can observe holds somewhere around 100 billion to 200 billion separate galaxies. Working from this perspective, stargazers reasoned that because the universe is packed with a seemingly boundless quantity of glowing, light-emitting structures in every single direction, it makes logical sense that every tiny section of the sky you decide to look at should hold thousands, if not hundreds of thousands of stars. This structural distribution should cause the nighttime sky to look completely and evenly glowing in every single direction. Detailed calculations imply that the overhead sky ought to match the intense brightness of the actual surface of the sun. Yet this is plainly not what we experience, a fact that left astronomers deeply confused. This is a deep contradiction that required nearly 3 centuries to completely untangle. The contradiction originally grew out of the steady-state model, which happened to be the most broadly embraced perspective regarding the cosmos during that historical era. The steady-state model claimed that the universe has always existed and will forever continue to remain precisely the way it appears to us today. Furthermore, it asserted that the universe was boundless in its dimensions, possessed no structural starting point, was perfectly uniform across all paths, and did not experience any form of expansion. The earliest attempts to smooth over this contradiction involved guessing that the vast majority of stars were simply located too incredibly far away to be spotted by human eyes. Nevertheless, this reasoning was quickly thrown out because the steady-state model itself stated that the universe had been around for an infinite duration of time. This infinite time would easily permit light radiating from even the most extraordinarily distant stars to complete the trip to our position, and add to a completely illuminated sky. Johannes Kepler came up with a totally different answer to this contradiction by directly disputing the claims of the steady-state model. Kepler put forward the idea that the stars throughout the cosmos only reached out to a limited finite distance. Past that specific boundary, an observer would run into nothing but completely empty space. While this concept appeared reasonable on the surface, this particular answer immediately triggered the follow-up inquiries. Exactly how far away is this outer edge, and what exists on the other side of it? On top of that, the concept of a limited, finite universe brought along serious scientific difficulties, such as the reality that it would ultimately pull itself together and collapse inward under the relentless gravity of its own stars and planets. This structural flaw forced the majority of stargazers to keep believing that the universe was boundless. And because of this, the contradiction and the steady-state model stayed exactly as they were, completely unresolved and largely overlooked. This state of affairs continued for nearly 2 full centuries until Heinrich Wilhelm Olbers, a highly celebrated German astronomer, injected fresh energy into the contradiction and once more put forward the question, why is the nighttime sky so dark? From that period onward, Olbers's name has been linked tightly to this specific paradox. Once again, the reigning perspective throughout his lifetime was that the universe was entirely motionless, infinitely ancient, and boundless in its spatial size. This time around, Olbers thought of a straightforward answer. If we make the assumption that the universe has no end, it is entirely logical to conclude that the non-transparent objects within it would likewise be infinite in total quantity, consisting of things like cosmic dust and space rocks that physically block the light coming from distant stars and cause them to look significantly dimmer. This cosmic dust slowly takes in and cuts off the travelling light of stars as it makes its way across the vastness of space. Even in our modern world, the majority of everyday people still believe in this particular concept, drawing direct connections between it and the exact way heavy clouds block out the light and view of the sun. Space rocks and cosmic dust could similarly block out the light arriving from distant stars. However, Olbers's highly persuasive answer still fails to fully untangle the scientific problem. This is because any cosmic rock or drifting dust particle would eventually warm up from the light and begin radiating the exact same absorbed energy back out into space. The universe would still hold the exact same volume of total radiation. The dust simply acts as a middleman, so to speak, positioned right between the light-producing stars and the person observing them. In the end, the total energy we pick up back on Earth would remain completely identical. So, what is the actual answer to this paradox? The real answer to the contradiction would only come to light after waiting for another full 100 years. In the year 1929, when Edwin Hubble looked through his incredibly powerful telescope, he was actually anticipating finding a universe that was pulling itself together and collapsing, since that observation would validate a limited, finite universe, precisely like Kepler had argued. But to his absolute astonishment, he uncovered that the universe was not collapsing inward at all. Instead, the distant galaxies were actively moving farther away from our position, behaving as if the actual space separating them was stretching out. As a matter of fact, the greater the distance to a galaxy, the quicker it was rushing away from us. The grand universe clearly does not seem to be falling inward, nor is it staying completely still, but it is actively expanding. This revelation immediately brought up a brand new question. If the universe is currently stretching out, what does that indicate about the state of the early universe? Cosmologists today are convinced that the universe was at one point unthinkably tiny and incredibly compressed. It then blew up in size at an extreme rate during an event known as a cosmic inflation. As this space stretched out, it naturally lowered its temperature, which eventually permitted stars and independent galaxies to take shape. This monumental realization ultimately cleared the path for the creation of the Big Bang theory as we understand it in modern times. Current scientists calculate that this foundational event took place roughly 13.8 billion years in the past. It stands as the single most mathematically precise framework for the origin of our cosmos today. The vast majority of modern scientists agree that the universe has a specific, finite age that trace back to that 13.8 billion year starting point. When we train our instruments on light that is 13.8 billion years old, it is not a case of us missing stars simply because their light has not had enough time to reach our position yet. We do not see any stars because we are literally catching a glimpse of the cosmos at a point in time before any stars had ever formed, a completely starless universe. The deeper we peer out into the distance, the further back into the timeline of history we are observing, right up until we hit the ultimate boundary of the universe. This boundary is not a physical wall, but is instead the remaining glow of the initial Big Bang, widely known as the cosmic microwave background. This represents the absolute most distant location in the entire universe that we can physically detect from our home on Earth. When we direct our advanced telescopes past the positions of the very earliest stars, we run right into this remnant light. This is absolutely not starlight, but rather the leftover radiation from the original Big Bang, creating a foundational backdrop that sits well beyond the stars. Yet, hold on a moment. The Big Bang theory seems to introduce a brand new complication. It asserts that the universe was drastically more luminous in its ancient history, particularly during the conclusion of the recombination epoch. Every single point in the local sky during that specific era matched the blinding intensity of the literal surface of the sun because of the extreme temperatures ruling the cosmos back then. Because of this, the cosmic microwave background ought to be completely dominating our nighttime skies right now on Earth. This would cause a permanent requirement for everyone to walk around wearing dark sunglasses all day long, just to avoid being completely blinded by the extreme luminosity of the surrounding universe. Fortunately, this outcome is completely neutralized by the reality that the universe is actively stretching out, and this expansion did not simply halt after the initial Big Bang occurred. Quite the opposite. The stretching has actually accelerated over time, meaning that brand new space is being continuously generated at a rate that is faster than the speed of light itself. At first glance, this detail might look like a direct breach of the core rules of special relativity, which explicitly state that absolutely nothing can travel through space at a velocity faster than the speed of light. In reality, it is not a violation at all. The continuous expansion of space is not caused by physical items rushing through the environment, but is instead driven by the literal stretching of space itself. This intense stretching is triggered by the operational impacts of dark energy, an unidentified, enigmatic force that is forcing the overall expansion of the universe to speed up constantly. This stretching of space is precisely calculated using a value known to science as the Hubble constant, which indicates the exact speed at which the cosmos is currently expanding. In our current era, the absolute finest calculations for the Hubble constant indicate that space is expanding at a speed of roughly 73.3 kilometers per second for every single megaparsec of distance. This rate means that the physical separation between any two coordinate points in space will completely double in size over a time frame of roughly 9.8 billion years. Now, as you are likely aware, light operates fundamentally as a wave, and as celestial objects travel farther away from our location, their travelling light waves get physically stretched out. The biological human eye is only capable of picking up a very specific range of light wavelengths, And when these wavelengths get stretched too long, they escape our visual capacity entirely. This physical shift is known as redshift, named because red holds the absolute longest wavelength of all the colours packed into our visible spectrum. For exceptionally far away cosmic objects, the travelling light waves get pulled out so drastically that they transform completely into infrared light, rendering them totally invisible to our naked eyes. So, in a very real way, the midnight sky is completely lit up with energy. We are simply unable to perceive it because of the strict biological limitations of our human eyes. However, specialised space telescopes possess the capability to see it, and that is precisely why we are able to capture such breathtaking images. So in the end, this is exactly how the true answer to the contradiction plays out. Because of the unyielding finite velocity of light combined with the fact that the universe possesses a specific finite age of roughly 13.8 billion years, we are strictly limited. This limited age means we can only ever observe stars and independent galaxies whose radiated light has had a sufficient window of time to complete the journey to our location. The relentless stretching of space-time makes this situation even more complicated in the deep outer zones of the cosmos. In those areas where space is actively expanding at a speed faster than the velocity of light, the light coming from those distant galaxies will never manage to outrun the expansion. No matter what actions we take or how many eons we sit and wait, we will never be capable of spotting the light coming from those specific galaxies. It will never illuminate our overhead skies. What we manage to view when we look out at the midnight sky is merely a microscopic slither of the entire existing cosmos. Stargazers refer to this specific zone as the observable universe, and we are completely unable, even with the most advanced instruments ever built, to look past this structural boundary. It does not simply represent a boundary in physical space. It functions equally as a boundary in time. Past the outer rim of our observable universe, the light will never be fast enough to outrun the spatial expansion. Because of this relentless stretching, if we project ourselves far into the future, approximately 100 billion years from this moment, let us imagine that we construct an incredibly advanced, powerful new telescope designed to let us study space far past our local galaxy. Yet, as we peer through the lens of this advanced device, we discover absolutely nothing. Nothing whatsoever but total blackness and completely empty space. The future generations of human beings living in that era will grow up understanding that they exist entirely inside a seemingly endless and nearly information-free wasteland. As the overall age of the cosmos climbs toward that 100 billion year mark, the continuous stretching of the universe will force all other independent galaxies to slide past the cosmic light horizon and vanish completely. This shift means that the light radiating from other galaxies will lose the ability to complete the journey to our position. To describe it differently, separate galaxies will be systematically pushed out past the borders of the observable universe, making it impossible to study them ever again. In our current time, we are losing about 20,000 individual stars every single second. When you really pause to think about it, we are extraordinarily lucky to be alive at a specific point in cosmic history, when we have open access to such a massive wealth of cosmic data. To be sure, there are an enormous number of mysteries regarding the cosmos that we do not fully comprehend yet, but at the very least we can hold on to the hope that one day we will crack them. In stark contrast, the distant future of 100 billion CE will be so completely starved of information that when the scientists of that era point their own versions of the Hubble telescope toward a seemingly vacant patch of space, the resulting picture returned to them will be completely blank. Of course, this exact reality applies to us today in a different way. we have absolutely no method for discovering what exists past the boundaries of our own observable universe. Yet one lingering question still remains. Why exactly are those historic photographs from the moon completely lacking any stars? Surely with absolutely nothing blocking the view, like a thick planetary atmosphere, we ought to be able to spot some stars glittering in the background frame. To unlock this, we have to look closely at how colour is actually generated in the world. Colour is a highly intricate relationship between travelling light and physical matter. Light is fundamentally made up of electromagnetic waves vibrating at many different wavelengths. And when this light bumps into an object, specific wavelengths are absorbed by that object, while other wavelengths are bounced back or passed right through. The colours that our eyes perceive are the direct consequence of the specific wavelengths of light that manage to bounce back to our visual receptors. To illustrate, if an item looks red to your eyes, it is because that specific item has absorbed every other colour packed into the visible spectrum, such as blue and green, and reflects only the red light back to your eyes. In the exact same way, if an item looks white, it is because it successfully bounces back every single colour of the visible spectrum at once, whereas an item that looks black absorbs all the incoming colours and bounces absolutely none of them back to our eyes. We are capable of seeing a beautiful blue sky here on Earth because the microscopic particles drifting in our atmosphere behave like miniature mirrors. The literal origin of the word atmosphere comes from atmos, which translates to vapour or atoms, and sphere, which translates to a globe. Throughout the nighttime hours, the sun drops below the horizon, and there is no longer an illuminated sky to block our direct view of the stars. On the lunar surface, however, there is zero atmosphere available to scatter the incoming light. Yet we still do not see stars in the photographs. This happens because the light radiating from the sun travels in a perfectly straight path without ever scattering, allowing all the individual colours to stay locked together. Therefore, when looking toward the sun, we see a glaring, brilliant white light. This is precisely what the Apollo astronauts experienced. Every single lunar touchdown took place entirely on the daylight side of the moon. Even though there was no atmosphere stretching over their heads, the intense reflection of the sun's light bouncing off the bright lunar dirt made their eyes temporarily unable to see dim objects. The extreme brightness and heavy glare coming from the sun completely blinded both the human spacefarers and their camera equipment to the subtle sight of the stars. Even so, one specific astronaut later noted that he could actually make out a few of the absolute brightest stars when he positioned himself inside the shadow cast by the lunar module, provided he looked straight up with his gold protective helmet visor lifted out of the way. Just imagine, though, if space explorers ever touched down on the dark night side of the moon and allowed their eyes to fully adjust to the near-total pitch-black environment, they would be treated to an absolutely breathtaking, jaw-dropping view of the stars. If our planet Earth lacked an atmosphere, then even our daytime sky would look exactly like the moon's. In our world today, when you factor in modern light pollution and the natural constraints of human biology, we can pick out roughly 3,000 individual stars during a clear night sky, and that number drops to a mere 300 stars on a night with a bright full moon. This dramatic difference is the exact reason why a number of scientists are convinced that it would be a phenomenal use of funding and time to construct a massive astronomical telescope directly on the far night side of the moon. The deep mystery of Olbers' paradox continues to stand as one of the most fascinating puzzles in all of modern cosmology, and its ultimate solution has gifted humanity a far more profound comprehension of the core nature and layout of our universe. When you take into account the millions of billions of Earth-like worlds floating out there, living things elsewhere in the cosmos undoubtedly do exist. Within the unfathomable emptiness of the universe, we are simply not alone. Albert Einstein. According to a highly detailed recent public poll managed by the Pew Research Center, a striking 2/3 of all American citizens now resolutely believe that extraterrestrial life is a reality, and at least 51% possess complete trust that the unusual UFO sightings reported by military service members are very likely genuine proof of intelligent life operating outside of Earth. Furthermore, when you look at the massive and revolutionary breakthroughs happening within modern astrophysics, current scientists strongly believe that there is an incredibly high statistical probability of tracking down definitive evidence of extraterrestrial intelligence within the next few decades. Seth Shostak, a highly respected astronomer working with the SETI project, the search for extraterrestrial intelligence, has confidently declared that in just a couple of decades we will without a doubt uncover concrete, undeniable evidence validating the existence of intelligent life past our home planet. As the human race throws its constantly growing net wider and wider across the enormous emptiness of the cosmos, mapping out data on thousands of foreign worlds, one single historical question continues to follow us. Is there actually anyone out there? The boundless wilderness of the cosmos, with its countless independent galaxies, stars and planets, makes it screamingly obvious that the core potential for life to take root exists elsewhere, even if we choose to believe that the initial spark of life on Earth was an extraordinarily rare, once-in-a-million event. The unmeasurable physical size of the universe still acts as a gigantic blank canvas for all kinds of life to pop up. It represents a cosmic landscape that could easily play host to intelligent creatures at completely different phases of structural growth, spanning all the way from the most primitive, least advanced groups to the most incredibly evolved civilizations. Just take a second to picture yourself completely isolated, floating weightlessly out in the massive void of space. The absolute quiet can feel completely deafening, and the emptiness can feel entirely crushing. At your first glance, you might completely believe that you are truly stranded, entirely cut off from any form of companionship. However, consider the deeply complex, buzzing, microscopic ecosystems that are actively thriving right inside our own biological bodies, worlds that we routinely take for granted and completely overlook. Uncountable numbers of microbes and tiny living organisms are going about their days right on your skin or deep inside your digestive tract. Their entire reality plays out completely unbeknownst to you. While these tiny creatures certainly do not possess anything close to our level of cognitive intelligence, their constant presence serves as an intense reminder that absolute loneliness is often nothing more than a trick of the mind. In a very similar fashion, the deeply ingrained idea that we are completely alone in the wide universe might also turn out to be a massive delusion. Completely hidden from our awareness, life sprinkled throughout the cosmos could be putting on a display of an enormous spectrum of intellect that we routinely and blindly ignore. Intellect is a truly spectacular characteristic that has completely built and defined our own history, and its physical expression can take on incredibly diverse and breathtaking forms across the wide open spaces of the universe. On exceptionally distant worlds, living creatures might have developed astonishing and completely unique mental skills, fine-tuned over time by highly specific environmental demands and distinct evolutionary tracks. Certain alien civilizations might be significantly less developed than our own, perhaps matching the primitive early eras of human history. They might rely on basic communication methods, utilize primitive tools, and hold a very restricted understanding of the surrounding universe. Meanwhile, on the completely opposite end of the spectrum, an abundance of highly advanced civilizations may have leaped far past our current achievements. These highly evolved beings might command an incredibly advanced level of intellect, allowing them to pull off extraordinary accomplishments in pure knowledge, technological creation, and deep interstellar travel. Their specific scientific breakthroughs and cultural structures could completely bypass our current mental capacity, making them seem practically godlike from our highly restricted viewpoint. The sheer variety of intelligence waiting in the cosmos easily blows past the boundaries of our absolute wildest dreams. The honest truth is that our self-congratulated human progress could turn out to be completely microscopic when measured on a true galactic scale. In our ongoing mission to gain a superior understanding of the massive universe and pinpoint our exact location within its layout, researchers and futurists have put together a variety of analytical scales and metrics. One particularly famous framework, known as the Kardashev scale, was brought forward by the Russian astrophysicist Nikolai Kardashev back in the year 1964. It presents a structured system for organising civilizations based entirely on their total energy consumption and their level of technological progress. This scale operates as a highly effective tool for indexing and thinking about our own future path as a biological species. The Kardashev scale is set up as a 4-level system that tracks a civilization's capacity to capture and put to work raw energy. The scale works from the core idea that a civilization's true level of technological growth is directly tied to the exact quantity of energy it can successfully control. A Type 1 civilization, often called a planetary civilization, commands the ability to capture and utilize every bit of energy that is naturally available on its home planet. This involves fully exploiting clean, renewable energy systems like solar power, wind currents, and geothermal heat to run their heavy industries and completely satisfy their societal energy needs. They have successfully pulled off global political unity and are fully capable of controlling the natural assets of their entire home world. A Type 2 civilization, alternatively known as a stellar civilization, commands the capacity to fully harvest the total energy output of their local sun. They are capable of building unthinkably massive engineering projects like Dyson spheres or giant Dyson swarms, designed to completely surround their star and trap its entire light output. This level of civilization can tap straight into the massive resources of their entire solar system, using them to power their ultra-advanced technologies and drive deep interstellar exploration. A Type 3 civilization, or a galactic civilization, would possess the ability to easily tap into the energy resources of an entire galaxy. They could casually rearrange the positions of planets, feed entire stars directly into ravenous black holes to harvest power, and even alter the literal fabric of space-time itself. Moving past that, a Type 4 civilization would be fully capable of generating an entire independent universe from scratch. When we grade ourselves using this specific scale, we have not even managed to secure a Type 1 civilization ranking yet, though we are definitely no longer stuck at a Type 0 baseline either. Modern human beings currently sit at a calculated score of approximately 0.73 on the Kardashev index. One highly prominent theoretical physicist has calculated that if we continue to scale up our global energy consumption by a steady 3% every single year, it will require somewhere between 100 to 200 years for us to officially cross over into a true Type 1 civilization status. The moment we finally lock in this advanced status, we will have the power to seamlessly harvest all the sunlight, wind power, and oceanic tides available across our globe. Global weather systems would be managed entirely by our human choices. We would possess the technology to redirect the paths of earthquakes and volcanic eruptions, and we would be constructing beautiful floating cities, In a remarkably similar way that mirrors the structured ranking of power usage, separate civilizations also demonstrate completely different strategies for sending messages, which can make it exceptionally tough for different species to comprehend one another. Type 1 civilizations, given their planetary level energy focus, are highly likely to depend on conventional communication channels that we recognize, such as classic radio waves, standard electromagnetic signals, and laser-focused optical communication. However, as they climb their way up the steps of the evolutionary scale, they will likely adopt technologies that open the door to vastly more advanced and highly efficient communication methods. Type 2 civilizations, to give an example, might comfortably use highly complex and ultra-sophisticated forms of long-range communication, such as focused gravitational wave transmissions or highly secure systems anchored in quantum entanglement. Type 3 civilizations, which are fully capable of casual intergalactic travel, might communicate using strategies that sit completely outside our current scientific comprehension, such as anchoring messages through stable wormholes, or sending signals across subspace channels. Finding a way to build a bridge across these technological gaps is absolutely vital for setting up functional and productive channels of mutual understanding. In order for two completely separate civilizations to execute a successful exchange, they would fundamentally need to settle on a shared, mutually recognizable platform for communication. Throughout our earliest steps as a developing Type 0 to 1 civilization, we chose to begin our journey by physically launching tangible, solid messages out into the deep void of space. These physical tokens, put together in several separate styles, operated as a basic tool to announce our physical presence and express our deep curiosity to the massive, silent unknown. Standing as the very first major organised projects designed to speak to potential extraterrestrial creatures, the historic Pioneer plaques and the Voyager Golden Records were securely attached to deep space probes launched on paths heading completely out of our solar system. The original plaques, designed under the guidance of the celebrated astronomer Carl Sagan and his dedicated team, displayed symbolic drawings representing humankind, which included a precise cosmic map charting our home location in the galaxy, alongside a simple silhouette of a human male and female figure. In a very similar manner, the Voyager Golden Record, meticulously assembled by a specialised committee under Sagan's direction, held a rich collection of natural sounds, cultural photographs, and diverse musical tracks put together to highlight the incredible variety of life and human culture thriving on Earth. In our modern era, those twin Voyager space probes have travelled to an astonishing distance of roughly 23 billion kilometres, or 14 billion miles, away from our homeworld, making them officially the most distant human-created objects currently in existence. Yet, while these historic messages beautifully illustrated our innate curiosity and our deep longing for contact, they simultaneously suffer from severe, massive constraints when it comes to actually pulling off functional communication. The sheer, unfathomable emptiness of space sets up a monumental obstacle when it comes to any alien species actually tracking down and spotting a physical token sent drifting into the dark. The tiny plaques and metal records launched out into the void are completely microscopic when measured against the unmeasurable spatial territory they are forced to cross. The universe is incredibly vast and mostly completely empty, making the mathematical odds of an extraterrestrial civilization accidentally bumping into our drifting plaques or records completely slim. On top of that, physical tokens like these plaques and records represent a completely one-way, unidirectional style of communication. They do an excellent job of stating our existence and our dreams, but they are completely missing any hardware to pick up or beam back live answers from any potential finders. Even if an ultra-advanced civilization happened to run right into these drifting messages by chance, the total lack of any integrated tool for them to reply directly completely stalls the creation of an actual conversation. This strictly one-way setup of physical messages drastically chokes off any potential for a live interactive swap of deep ideas, scientific data, and cultural perspective between separate worlds. Finally, the unthinkably massive distances separating different celestial structures mean that the physical journey of these solid tokens will drag on for hundreds or even thousands of years. In the specific case of the Voyager Golden Records, as an example, it would require absolute eons for any potential answer to make the trip back to our planet. These sluggish timescales tied to physical interstellar transit make it completely useless for prompt or real-time conversations, completely blocking the path for timely interaction and mutual group learning. After spending more than 60 long years actively broadcasting all sorts of artificial signals out into space and meticulously scanning the overhead skies trying to catch a stray artificial transmission from somewhere else, we have failed to locate anything at all. We remain completely unheard across the dark. In our current era, the premier international organisation fully committed to the systematic hunt for non-human civilizations is a highly organised project known as SETI, an acronym that stands directly for the search for extraterrestrial intelligence. This scientific endeavour is built heavily around the continuous operation of massive radio telescopes. These specialised radio dishes are designed to collect incoming radio waves because we lack the technology to physically launch crews across the universe aboard starships to track down intelligent life. Instead, what we actively hunt for are artificial radio signals. Dedicated researchers utilise these massive radio telescopes scattered all over our globe to systematically audit the overhead skies, hunting for highly specific, narrow-band signals that clearly and unmistakably pop out against the random background hiss of natural cosmic noise. This method effectively permits human scientists to try and eavesdrop directly on the faint whispers travelling through the universe. It behaves exactly like adjusting your personal FM radio dial to locate the precise matching frequency of a local broadcasting station. Because of this, researchers concentrate their search efforts heavily on signals located inside what is known as the water hole frequency spectrum. This specific band comfortably bridges the territory between the natural hydrogen line and the hydroxy line. The driving logic is that these specific frequencies represent the absolute most natural universal options for interstellar communication because of their close location on the electromagnetic spectrum to the natural radiostatic emitted by hydrogen and hydroxy, two elements that happen to be completely abundant throughout the entire universe. However, a massive towering obstacle stands squarely in our path: the language barrier. Shared language functions as the literal bedrock for all human interaction, enabling us to cleanly pass complicated ideas, deep feelings, and hard-earned knowledge down through the generations. But when we try to apply this concept to non-human, extraterrestrial entities, the foundational idea of what a language even is becomes exceptionally difficult to grasp. How could we ever hope to break the complex communication codes of a completely alien civilization? What bizarre variations of communication would they choose to use? Today we find ourselves losing approximately 20,000 stars every single second. And when you really pause to think about it, we are incredibly lucky to live at a point in the timeline of the universe where we have access to such an immense wealth of information. To be sure, there are still many deep secrets about the outer cosmos that we do not fully grasp right now, but at the very least there is real hope that one day our future generations will solve them. On the other hand, the people living in the distant future, around 100 billion years from today, will be so completely starved of cosmic data that when they direct their own versions of the Hubble telescope toward a seemingly dark patch of the sky, the image they get back will be completely empty. Of course, a similar truth holds for us in the present day, because we have no real way of knowing what lies past the boundaries of our own observable universe. Yet one last question continues to puzzle us, which is why these pictures taken on the surface of the moon are completely empty of any stars. Surely with absolutely nothing blocking the view, such as a thick planetary atmosphere, we should be able to clearly see some stars twinkling in the dark background. To fully understand this, we have to look at how colour is actually produced in the physical world. Colour is the result of a highly complex interaction that takes place between travelling light and physical matter. Light itself is made up of moving electromagnetic waves that possess many different wavelengths, and when this light strikes a physical object, some of those specific wavelengths are absorbed by the object, while other wavelengths are reflected away or transmitted onward. The specific colours that our eyes perceive are entirely a product of the precise wavelengths of light that end up being reflected straight back to our vision. For instance, if a certain object looks red to us, it is simply because that object has completely absorbed all the other colours across the visible spectrum, like blue and green, and it reflects only the red light back into our eyes. In a similar way, if an object looks bright white to our eyes, it is because it reflects all the combined colours of the visible light spectrum together, while an object that looks solid black absorbs every single colour and reflects absolutely nothing back to our sight. We are capable of seeing a beautiful blue sky on Earth simply because the various gas particles drifting in our atmosphere function like tiny mirrors. The actual word atmosphere literally means vapour, or atoms combined with the word for a globe. During the nighttime hours, the sun sets below the horizon, and there is no bright blue sky left to block our direct view of the stars. On the surface of the moon, however, there is no atmosphere present at all to scatter the incoming light. But even so, we still do not see stars in the photographs. This happens because the light coming from the sun travels in a perfectly straight path without ever being scattered by gas particles, so all the different colours remain bundled together. When looking directly toward the sun, we see nothing but an incredibly brilliant white light. This is exactly the situation that the Apollo astronauts encountered during their historic missions. Every single lunar landing was scheduled to take place on the bright day side of the moon. Even though there was no air or atmosphere above their heads, the intense reflection of sunlight bouncing off the bright lunar dirt made their eyes temporarily unable to see faint objects. The extreme brightness and blinding glare from the sun completely overwhelmed their eyes and their camera sensors, preventing them from picking up the faint light of the stars. Even so, one astronaut mentioned that he could actually see a few of the brightest stars when he stood completely inside the dark shadow of the lunar module and looked straight up with his gold protective helmet visor raised up. Just imagine if astronauts were to land on the dark night side of the moon and let their eyes fully adjust to the pitch black surroundings. They would be treated to an absolutely breathtaking view of the star-filled sky. If our own planet Earth had no atmosphere surrounding it then, even our daytime sky would look exactly like the black sky of the moon. Right now, when we take into account the heavy light pollution from our cities and the natural physical limits of human eyes, we can see roughly 3,000 individual stars during a clear night sky, and only about 300 stars when there is a bright full moon shining. This is the primary reason why a number of modern scientists believe it would be an excellent idea to spend the necessary money and time to construct a massive astronomical telescope on the quiet night side of the moon. The deep riddle of Olbers' paradox continues to be one of the most fascinating mysteries in all of modern cosmology, and finding its solution has given humanity a far deeper understanding of the fundamental nature and architecture of our entire universe. When we consider the millions and billions of Earth-like planets scattered across space, life somewhere else in the cosmos undoubtedly exists. In the grand vastness of the universe, we are certainly not alone, as noted by the famous physicist Albert Einstein. According to a highly detailed public opinion study conducted by the Pew Research Center, 2/3 of all Americans now strongly believe that intelligent alien life exists somewhere out there, and at least 51% have complete confidence that the strange UFOs reported by military personnel are likely direct proof of intelligent life originating outside of Earth. And when you look at the major and revolutionary discoveries being made in modern astrophysics, scientists today firmly believe that there is an incredibly high probability that we will detect extraterrestrial intelligence within the next few decades. Seth Shostak, who is a highly respected astronomer working at the SETI Institute, which searches for extraterrestrial intelligence, has confidently declared that in just a couple of decades, humanity will definitely discover undeniable physical proof confirming that intelligent life exists beyond our home planet. As human beings cast their constantly growing technological net across the vast spaces of the cosmos, identifying the presence of thousands of distant alien worlds, one ancient question still returns to haunt us, which is whether anyone is actually out there listening. The immense scale of the cosmos, with its countless billions of galaxies, stars and planets, makes it incredibly obvious that the right conditions for life to develop must exist somewhere else. Even if we choose to accept the idea that the initial spark of life on Earth was an incredibly rare event, the sheer physical size of the cosmos provides a massive blank canvas for all kinds of diverse life forms to appear. It is a cosmic landscape that could easily support intelligent living beings at completely different stages of growth, ranging from the most simple and least advanced to the highly evolved and sophisticated. Just try to picture yourself completely alone, floating weightlessly in the deep silence of outer space. The complete lack of sound can be absolutely deafening, and the surrounding emptiness can feel entirely overwhelming. At your first glance, you might truly believe that you are totally isolated from the rest of existence and completely cut off from companionship. However, you should stop to contemplate the incredibly complex ecosystems that are thriving right now inside your own body, which we regularly take for granted and completely ignore. Countless microbes and tiny microscopic organisms are living on the surface of your skin or deep inside your digestive tract, and their daily existence happens completely without your knowledge. While these tiny organisms certainly do not possess our high level of human intellect, their constant presence serves as a powerful reminder that our feelings of absolute solitude can often be nothing more than an illusion. In the exact same way, the widespread idea that we are totally alone in the giant universe might also turn out to be a complete delusion. Entirely unknown to us, life throughout the wider universe could be displaying an immense range of intellect and awareness that we simply overlook. Intellect is a truly extraordinary characteristic that has deeply shaped our own human existence, and its outward expression can take incredibly diverse and fascinating forms across the wide expanses of the universe. On distant alien planets, strange creatures might have developed remarkable and exceptional mental skills that were sharpened over time by unique environmental challenges and distinct evolutionary paths. Some alien civilizations might be significantly less advanced than our own, perhaps being quite comparable to the very early periods of human tribal development. They might only have basic methods of communication, primitive physical tools, and a very limited grasp of the wider universe surrounding them. Meanwhile, on the opposite end of the spectrum, many highly advanced alien civilizations may have progressed far past our current human capabilities. These highly evolved beings might possess an unimaginably advanced intellect that allows them to perform extraordinary feats of scientific knowledge technology and long-distance interstellar travel. Their incredible scientific discoveries and cultural breakthroughs could completely transcend our current human ability to understand, making them appear almost godlike from our very limited point of view. The incredible variety of intelligence in the cosmos easily goes past the boundaries of our absolute wildest dreams. The simple truth is that our own highly praised human progress might actually be completely minuscule when it is viewed on a true galactic scale. In our ongoing effort to get a better understanding of the immense universe and find our true place within it, modern scientists and futurists have created several scales and measurements. One particularly famous measurement is the Kardashev scale, which was originally suggested by the famous Russian astrophysicist Nikolai Kardashev back in the year 1964. This scale offers a very clear framework for sorting different civilizations based entirely on their total energy consumption and their level of technological progress. The scale functions as a highly effective tool for analysing and thinking about our own future path as a biological species. The Kardashev scale is set up as a 4-tiered system that tracks how well a civilization can collect and control energy. The entire scale rests on the core idea that a civilization's level of technological progress is directly linked to the total amount of energy it can control. A Type 1 civilization, which is often called a planetary civilization, has developed the capability to collect and utilize every bit of energy that is available on its native home planet. This involves fully utilizing clean renewable energy sources, such as solar power, wind power, and geothermal energy, to run their massive industries and fulfill all their societal energy requirements. They have successfully established global unity across their world and are fully capable of controlling the natural resources of their entire planet. Moving up a Type 2 civilization, which is also known as a stellar civilization, has achieved the ability to harness the entire energy output of their local host star. They are capable of building giant space structures like Dyson spheres or massive Dyson swarms that completely surround their star to capture all of its radiant energy. This kind of advanced civilization can easily tap into the immense resources of their entire solar system and use them to power their highly advanced technologies and fuel their deep interstellar space exploration. Next, a Type 3 civilization, which can be called a galactic civilization, is capable of utilizing the energy resources of an entire galaxy. They can physically move entire planets around, feed massive stars into black holes to harvest power, and even directly alter the fundamental fabric of space and time. Finally, a Type 4 civilization would possess the unimaginable power to create an entirely new universe all on its own. According to the metrics of this scale, humanity has not yet managed to reach the level of a Type 1 civilization, but we are certainly not a simple Type 0 civilization anymore. Human beings currently have a calculated score of roughly 0.73 on the Kardashev scale. One very prominent theoretical physicist has calculated that if we continue to expand our global energy consumption by about 3% every single year, it will take humanity somewhere between 100 and 200 years to finally reach a true Type 1 civilization status. Once we successfully reach this evolutionary point, we will be able to fully capture all of the sunlight, wind power, and ocean tides that hit our world. Global weather conditions will be managed completely by our own choice, and we will possess the technology to change the path of destructive earthquakes, stop volcanic eruptions, and build massive floating cities in the sky. In a very similar way, that mirrors the organised sorting of planetary power, usage. Different civilizations also develop completely separate methods for communicating, which can make it incredibly tough for them to interact with or understand one another. Type 1 civilizations, because of their planetary scale of energy usage, are highly likely to depend on classic communication tools, such as standard radio waves, electronic signals, and basic optical laser communication. However, as these societies climb higher up the evolutionary scale, they will likely master technologies that open the door to far more advanced and highly efficient communication systems. Type 2 civilizations, for example, might regularly use highly sophisticated methods of long-distance space communication, like sending focused gravitational waves or using communication networks based entirely on quantum entanglement. Type 3 civilizations, which are fully capable of travelling between different galaxies, might use communication methods that are completely beyond our current scientific understanding, such as sending data through stable wormholes or using subspace communication networks. Finding a way to cross these massive communication gaps is absolutely essential for creating useful channels of shared understanding across the stars. In order for two separate alien civilizations to communicate with each other successfully, they would first need to find and agree upon a shared method of communication. During our own early steps as a developing Type 0 to Type 1 civilization, we started our journey by launching physical messages out into the deep dark of outer space. These messages, which were sealed in various durable forms, were meant to broadcast our physical presence and our scientific curiosity to the giant unknown universe. As part of our very first serious attempts to connect with potential extraterrestrial neighbours, the famous Pioneer plaques and the Voyager golden records were carefully attached to deep space probes sent far past the edges of our solar system. The Pioneer plaques, which were famously designed by the astronomer Carl Sagan and his dedicated team, featured symbolic illustrations of humanity, including a detailed map showing our precise location in the Milky Way galaxy, alongside a drawing of a human male and female figure. In a similar fashion, the Voyager Golden Record, which was assembled by a special committee led by Sagan, contained a rich collection of natural sounds, photographs from Earth and various pieces of music to show off the wonderful diversity of life and culture on our planet. Right now, those Voyager space probes are located more than 23 billion kilometres or 14 billion miles away from our home planet, which officially makes them the most distant human-made objects currently in existence. But even though these physical messages beautifully illustrated our human curiosity and our deep longing for contact, they also come with severe practical limitations when it comes to creating real communication. The sheer vastness of empty space creates an incredible obstacle when you are trying to locate or bump into a tiny physical message floating in the cosmos. The metal plaques and record discs that we launched out into space are completely microscopic when compared to the unbelievably massive regions of space that they must travel through. Space is incredibly vast and mostly empty, which makes it highly improbable that any extraterrestrial civilization will ever happen to stumble upon our plaques or records by pure luck. Furthermore, physical messages like these plaques and records represent a completely one-way form of communication. They work well as a static showcase of our human existence and our dreams, but they are totally incapable of receiving or sending back live replies from any potential alien finders. Even if a highly advanced alien society were to discover these messages one day, the total lack of an immediate way for them to answer back completely stops the start of a real conversation. This one-way design of physical messages heavily restricts the chances for an active exchange of new ideas, scientific knowledge, and deep cultural understanding between separate civilizations. Finally, the massive physical distance separating different stars and planets mean that the lonely journey of these physical messages will drag on for hundreds or even thousands of years. In the specific case of the Voyager Golden Records, it would easily take absolute eons for any kind of reply from an alien world to travel back to Earth. The massive timescales that are required for interstellar communication make it totally useless for quick or real-time conversations, which heavily blocks the chances for fast interactions and shared learning between worlds. After spending more than 60 long years broadcasting all kinds of electronic signals out into the cosmos and carefully searching the night skies to discover artificial signals from other worlds, we have still not managed to find anything at all, and humanity continues to remain entirely unheard in the dark. Nowadays, the premier scientific institution on Earth that is completely dedicated to searching for extraterrestrial life is a global project known as SETI, which is an acronym that stands for the Search for Extraterrestrial Intelligence. This massive project relies heavily on the use of large radio telescopes. These specialised radio telescopes are designed to catch incoming radio waves because we cannot physically travel through space aboard our current spaceships to hunt down intelligent life. So what we must look for instead are artificial radio signals. Scientists regularly use these massive radio telescopes located all around the world to scan the deep sky for specific narrowband signals that clearly stand out against the background of natural cosmic noise. This technology allows our scientists to effectively listen in on the quietest whispers of the universe. It works very much like twisting the dial on your car's FM radio to locate the exact matching frequency of a local radio station. Scientists frequently focus their search for alien signals within a specific frequency band known as the water hole. This frequency range covers the space between the natural hydrogen line and the hydroxyl line. The core theory is that these particular frequencies are the most logical choices for interstellar communication because they are located very close in the electromagnetic spectrum to the natural radio emissions of hydrogen and hydroxyl, which are the two most common elements found across the entire universe. Even so, a truly massive obstacle continues to block our path forward, which is the profound language barrier. Human language functions as the absolute foundation of all communication on Earth, allowing us to share complex ideas, deep emotions, and scientific knowledge with one another. But when we start to think about communicating with extraterrestrial entities, the entire concept of language becomes incredibly difficult to comprehend. How can we possibly expect to understand them if their minds evolved in a completely alien environment? Language serves as the absolute bedrock of human communication, allowing us to convey complex ideas, deep emotions, and vast knowledge to one another across generations. But when it comes to communicating with potential extraterrestrial beings, the very notion of language becomes incredibly difficult to comprehend or predict. How can we possibly expect to understand them if their minds evolved in a completely separate alien environment? On Earth, our languages are deeply intertwined with our biological senses, our evolutionary history, and our unique physical environment. We speak using sound waves that travel through a specific mixture of nitrogen and oxygen, and we write using symbols that assume a certain visual acuity. An alien species might not have ears or eyes. They might communicate through changing colour patterns on their skin, variations in magnetic fields, or the release of complex chemical sequences. Because their entire evolutionary path would be fundamentally distinct from ours, finding a common ground for language presents an almost insurmountable conceptual hurdle. This is why many scientists believe that standard human languages, whether spoken or written, would be entirely useless for interstellar communication. If we ever do receive a deliberate signal from a distant star system, it will not be written in English, Mandarin, or any other earthly tongue. Instead, it will be wrapped in a completely alien architecture of information that we will have to figure out how to decode from scratch. To cross this profound communication gap, scientists have long suggested that we must look for a universal language that does not depend on cultural history or biological quirks. The most logical candidates for this universal language is mathematics, along with the fundamental laws of physics. Across the entire cosmos, 2 plus 2 will always equal 4, and the structure of a hydrogen atom remains exactly the same whether you are on Earth or in a galaxy billions of light years away. It is highly probable that any technological civilization advanced enough to build a radio transmitter would have a deep and precise understanding of mathematics and physics. Therefore, the first attempts to construct intentional messages for outer space have relied heavily on mathematical principles. For instance, in the year 1974, a famous broadcast known as the Arecibo message was beamed toward a distant star cluster. This message was composed entirely of a sequence of binary ones and zeros. The total number of bits in the message was intentionally chosen because it was the product of two prime numbers, 19 and 73. The core idea was that an intelligent alien recipient would recognize this mathematical pattern and arrange the binary bits into a two-dimensional grid, which would reveal a pictograph showing basic information about humanity, our DNA structure, and our solar system. By using the universal language of mathematics and basic geometry, scientists hope to bypass the language barrier entirely and establish a clear, logical channel of communication across the stellar void. Even if we manage to solve the language problem through the universal principles of mathematics, another massive challenge arises from the sheer physical scale of the cosmos and the absolute speed limit of the universe. The laws of physics dictate that nothing can travel through space faster than the speed of light, which moves at roughly 300,000 kilometers per second. While this speed seems incredibly fast on a planetary scale, it is painfully slow when measured against the enormous gaps separating different stars. The closest star system to Earth, Alpha Centauri, is located more than 4 light years away, meaning that a radio signal sent from Earth today would take over 4 years just to arrive there, and any potential reply would take another 4 years to return to us. This means a single exchange of basic greetings would require nearly a decade to complete. If we look further out into the galaxy towards stars located hundreds or thousands of light years away, the timeline for communication stretches into centuries or millennia. This extreme delay completely eliminates the possibility of having a real-time, fluid conversation with an extraterrestrial civilization. Instead of a live dialogue, interstellar communication becomes a slow, multi-generational archive of messages sent across time and space. A civilization might send a message out into the dark, and by the time the reply finally arrives back at their homeworld, that original civilization might have already collapsed or evolved into something entirely different. The profound silence that we encounter when we look up at the star-filled sky is not just a scientific puzzle, it is also a source of deep philosophical reflection that challenges our understanding of our place in the universe. For decades, human beings have harboured a deep-seated longing for contact, a psychological desire to know that we are not completely alone in this vast, dark expanse. This yearning has inspired countless works of science fiction, fueled scientific research, and driven us to build massive technological eyes to peer into the cosmos. Finding undeniable proof of another intelligent civilization would be the most transformative event in human history, instantly shattering our anthropocentric worldview and opening up a completely new chapter for our species. It would force us to rethink our philosophy our religions, our politics, and our collective identity as inhabitants of Earth. Yet as the years roll by and our radio telescopes continue to record nothing but empty static, the silence can feel increasingly heavy and unsettling. It forces us to confront the uncomfortable possibility that intelligent life might be an incredibly rare, fragile anomaly in a universe that is otherwise entirely indifferent to our existence. This realization highlights the immense value and fragility of our own civilization, suggesting that we must take full responsibility for our survival, because there may be no one out there coming to save us or guide us. This eerie mismatch between the high mathematical probability of extraterrestrial life and the complete lack of any visible evidence or contact is a famous scientific dilemma known as the Fermi paradox. The paradox is named after the brilliant Italian-American physicist Enrico Fermi, who famously raised the question during a casual lunchtime conversation with his colleagues in the year 1950. Fermi reasoned that the universe is incredibly old, spanning nearly 14 billion years, and it contains billions of star systems that are much older than our own Sun. Many of these ancient stars host planets that are remarkably similar to Earth, providing environments where life could have theoretically emerged and evolved over billions of years. If even a tiny fraction of these planets developed intelligent species that mastered interstellar travel, they would have had more than enough time to explore, colonize, and reshape the entire Milky Way galaxy. By all logical calculations, the galaxy should be teeming with visible signs of advanced alien engineering, massive communication networks, and travelling starships. Yet, when we look out into the night sky with our most advanced scientific instruments, we see absolutely no physical proof of their existence. The universe appears to be completely empty, quiet and devoid of any technological activity, creating a baffling contradiction that modern science is still struggling to explain. To resolve the deep mystery of the Fermi paradox, scientists and philosophers have proposed a wide variety of theoretical explanations, which are often grouped into a concept known as the Great Filter. The Great Filter theory suggests that there is a monumentally difficult evolutionary hurdle or barrier somewhere along the path from a simple, lifeless planet to an advanced, spacefaring civilization. This barrier is so incredibly difficult to cross that almost no species manages to survive the transition. The critical question that humanity must face is where exactly this great filter is located in our own timeline. If the filter is located far behind us in our evolutionary past, it means that the development of complex life or intelligent minds is an extraordinarily rare fluke, and we are incredibly lucky to have made it this far. In this scenario, the universe is mostly empty because the initial spark of intelligent life is almost impossible to achieve. On the other hand, if the great filter lies ahead of us in our future, it means that many alien civilizations may have reached our current level of technological progress, but they all inevitably hit a catastrophic wall and went extinct before they could successfully expand into outer space. This implies that humanity faces an upcoming existential threat that could completely wipe us out, whether through self-destruction, environmental collapse, or some unknown technological catastrophe. One of the most prominent explanations for a future great filter is the inherent danger of technological self-destruction, a grim reality that humanity has had to confront directly since the middle of the 20th century. As a civilization advances scientifically, it inevitably unlocks increasingly powerful and dangerous forces such as nuclear energy, advanced biotechnology, and artificial intelligence. The development of these technologies provides immense benefits, but it also creates existential risks that can accidentally or deliberately destroy an entire planet. If the moral and social development of an intelligent species fails to keep pace with its rapidly growing technological power, it becomes highly likely that they will eventually destroy themselves. A civilization might unleash a devastating global nuclear war, accidentally create a lethal engineered pandemic, or lose control of a super-intelligent machine network. From a cosmic perspective, the window of time during which a civilization possesses high technology before destroying itself might be incredibly brief, lasting only a few centuries. This would mean that the galaxy is filled with the silent radioactive ruins of advanced worlds that burned out quickly, leaving behind nothing but empty space and unanswered questions for anyone else who might be looking. Another fascinating explanation for the cosmic silence is known as the zoo hypothesis, which suggests that advanced extraterrestrial civilizations are fully aware of our existence but are deliberately choosing to avoid any contact with us. According to this theory, the galaxy might be carefully managed by a highly advanced interstellar community that follows a strict policy of non-interference when dealing with young, primitive species like humanity. They might view planet Earth as a protected wilderness area, a nature reserve, or a cosmic zoo where we are allowed to evolve naturally and develop our own culture without any outside disruption. In this scenario, alien observers might be hiding their presence using incredibly sophisticated cloaking technology, quietly monitoring our television broadcasts, our scientific progress, and our global conflicts from a safe distance. They might be waiting for humanity to reach a certain level of technological maturity, global unity, and ethical development before they finally decide to make themselves known and invite us to join the wider galactic community until we manage to outgrow our primitive tendencies toward warfare and tribal division. We will remain completely isolated inside our cosmic quarantine, looking out at a sky that is artificially kept quiet. A much darker and more terrifying perspective on the Fermi paradox is offered by a concept known as the dark forest theory, which was popularized by modern science fiction literature. The dark forest theory views the entire universe as a dangerous, predator-filled jungle where every civilization acts like an armed hunter moving stealthily through the trees. In this grim landscape, survival is the absolute primary directive for every living species, and space resources are fundamentally limited because it's completely impossible to know the true intentions of an alien civilization with total certainty, and because technological progress can explode exponentially over short periods. Any newly discovered civilization represents an immediate existential threat. If a hunter detects another creature moving in the dark forest, the most logical and safe action is to eliminate that creature immediately before it can grow powerful enough to become a threat. Therefore, advanced civilizations choose to remain completely silent, hiding their presence and masking their electronic signatures to avoid detection. According to this theory, the reason we hear no signals from outer space is that any civilization foolish enough to broadcast its location loud and clear is quickly wiped out by hidden predators. By sending out physical messages and radio signals into the cosmos, humanity might be accidentally announcing its existence to a hostile universe, acting like a child, lighting a campfire inside a dark forest full of dangerous monsters. Alternatively, the solution to the Fermi paradox might not involve hostile predators or self-destruction, but rather a natural transition toward a completely digital, indoor existence, an idea known as the transcension hypothesis. This theory suggests that as advanced civilizations evolve, they eventually lose all interest in exploring the cold, empty expanses of physical outer space. Instead, they choose to focus their immense technological power inward, exploring the infinite possibilities of microscopic spaces and hyper-advanced virtual realities. They might upload their entire collective consciousness into massive, planet-sized supercomputers or quantum networks that run on highly efficient energy sources. Inside these perfect digital worlds, they can experience infinite lives, create flawless societies, and manipulate simulated universes at speeds that are millions of times faster than real-time physical existence. To maximize their computational efficiency and energy usage, these digital civilizations might compress themselves into incredibly dense structures located near dark, stable energy sources, such as black holes. From our primitive physical point of view, these worlds would look completely dark, silent, and indistinguishable from natural cosmic objects, meaning that advanced life is thriving all around us, but it is living inside an invisible, simulated realm that we cannot perceive. Furthermore, we must consider the possibility that human technology is still far too primitive to detect the highly sophisticated communication networks that advanced alien societies are regularly using. Right now, our search for extraterrestrial intelligence relies almost entirely on monitoring basic electromagnetic frequencies and traditional radio waves, which are technologies that humanity has used for little more than a single century. An advanced alien civilization that is thousands or millions of years ahead of us would have likely abandoned standard radio waves eons ago, viewing them as an incredibly slow, noisy, and inefficient way to send data across long distances. They might communicate using tightly focused laser beams, arrays of modulated gravitational waves, or advanced networks based entirely on quantum entanglement, which allows information to be shared instantly across vast distances without any physical delay. Our current radio telescopes would be completely blind to these advanced signals, meaning that we are currently acting like primitive people trying to catch a modern digital satellite broadcast using a simple smoke signal or a stone tool. The galaxy could be completely filled with a roaring, high-speed interstellar internet, but we are simply unable to plug into the network because we lack the necessary scientific understanding and technological tools. In addition to our technological limitations, we must also recognise the profound physical and environmental barriers that make long-distance interstellar travel an incredibly difficult, if not impossible, challenge for biological organisms. The immense distances between star systems mean that even a spaceship travelling at a significant fraction of the speed of light would require decades or centuries to reach the nearest alien world. For a biological species, like human beings, a journey of this length creates massive logistical and medical obstacles. Prolonged exposure to cosmic radiation in deep space can damage DNA and cause fatal illnesses, while extended periods of zero gravity lead to severe muscle wasting and bone loss. To survive a journey across the stars, a biological crew would need a massive spacecraft that can support a complete closed-loop ecosystem for multiple generations, meaning that the people who finally arrive at the destination would be the distant descendants of the original crew. These harsh physical realities suggest that the classic science fiction dream of travelling from planet to planet inside small, fast starships might be completely unfeasible, explaining why no alien species has ever arrived on Earth to shake our hands. Because of these extreme biological limitations, it is highly probable that the true pioneers of interstellar exploration will not be flesh and blood creatures, but rather artificial intelligence and autonomous robotic probes. A highly advanced civilization looking to map the galaxy would likely construct millions of tiny, self-replicating robotic spacecraft, which are frequently called von Neumann probes. These smart probes would be programmed to travel to distant star systems, harvest local raw materials from asteroids or moons, and use that material to build exact copies of themselves. These new probes would then be launched toward the next set of nearby stars, creating an exponentially growing wave of robotic explorers that could completely map and analyse an entire galaxy in a relatively short period of time. Because these machines do not require food, water or oxygen, and because they are completely immune to the damaging effects of cosmic radiation and deep space boredom, they are perfectly suited for the harsh realities of long-distance space travel. If advanced civilizations are common throughout the cosmos, the night sky should be filled with these tiny robotic sentinels quietly monitoring our planet. Yet our sensors have failed to pick up any trace of artificial machinery orbiting our world. When we carefully weigh all of these diverse theories and scientific perspectives, we begin to realize that the search for life in the universe is a journey that requires an immense amount of patience, humility, and rigorous scientific dedication. We are currently standing at the very beginning of our cosmic exploration, having examined only a tiny, microscopic drop in a vast planetary ocean of space. The lack of an immediate answer or a sudden radio signal should not be viewed as a definitive sign of failure, but rather as an invitation to keep pushing the boundaries of our knowledge, building more powerful telescopes and exploring the unknown with an open mind. Whether we eventually discover a galaxy teeming with diverse intelligent civilizations, or we find out that we are truly alone in the absolute emptiness of the dark void, the answer will be deeply profound and completely redefine the human experience. Until that historic day arrives, we will continue to look up at the night sky, sending our electronic whispers out into the silence, driven by an ancient, unstoppable curiosity to discover our true home among the stars. When we shift our attention away from the grand search for alien signals and look closer at our own local cosmic neighbourhood, we encounter a whole different set of bizarre phenomena that leave scientists completely baffled. For decades, our spacecraft have been travelling to the outer edges of the solar system, passing by giant planets and sending back invaluable data. But during these routine journeys, astrophysicists noticed something truly strange happening that completely defied the standard mathematical models of gravity. When a space probe flies close to a massive planet like Earth or Jupiter to perform a gravitational slingshot manoeuvre, a common technique used to gain extra speed and conserve fuel, it experiences an unexpected tiny kick in velocity. This sudden unexplained increase or decrease in speed is known to the scientific community as the flyby anomaly, and it represents one of the most persistent and frustrating mysteries in modern orbital mechanics. The very first time scientists clearly identified this unusual phenomenon was in the year 1990, when the Galileo spacecraft executed a close flyby of Earth on its long, looping journey to the planet Jupiter. As the mission controllers at NASA meticulously tracked the probe's radio signals to calculate its precise trajectory, they discovered that its actual velocity after passing Earth was ever so slightly higher than what Isaac Newton's laws of gravity and Albert Einstein's theory of general relativity had predicted. The difference was incredibly minuscule, amounting to just a few millimeters per second. But to an aerospace engineer tracking a multi-million-dollar spacecraft across millions of miles, it was a glaring discrepancy that could not be easily ignored or written off as a simple rounding error. At first, the engineers assumed that some minor technical glitch had occurred in their tracking equipment, or perhaps a tiny burst of gas had leaked from the spacecraft's thrusters, generating an artificial push. However, after conducting a thorough, exhaustive investigation of the ship's mechanical systems, they found absolutely no evidence of leaks, system failures, or sensor malfunctions. The mystery deepened significantly a few years later, in the year 1998, when another deep space probe called Near Shoemaker swept past Earth to gain the necessary orbital energy to reach its target asteroid. Once again, as the spacecraft made its closest approach and began to pull away into deep space, tracking systems picked up a sudden, spontaneous shift in its speed. This time, the unexplained velocity change was even larger than what Galileo had experienced, leaving the scientific team completely stunned. It was now abundantly clear that the Galileo incident was not an isolated fluke or a one-time tracking error. Instead, they were dealing with a real, repeatable physical phenomenon that seemed to consistently occur whenever a human-made machine interacted closely with a planet's gravitational field. In the years that followed, similar unexplained velocity anomalies were recorded during planetary flybys executed by other high-profile space missions, including the Rosetta Comet Chaser and the Messenger probe on its way to Mercury, cementing the flyby anomaly as a genuine astronomical puzzle. To figure out what was causing these bizarre speed variations, teams of physicists and orbital mathematicians all over the world began to carefully analyse every single variable that could possibly influence a spacecraft's flight path. They investigated the subtle drag caused by the absolute outermost layers of Earth's atmosphere, thinking that perhaps the air was denser than previously estimated. However, detailed calculations quickly proved that atmospheric resistance would actually slow the spacecraft down rather than speed it up, and the effect was far too weak to account for the observed changes anyway. They then looked into the physical impact of solar radiation pressure, which is the gentle push exerted by travelling particles of sunlight hitting the spacecraft's metal body, while solar pressure is a real force that must be accounted for in deep space navigation. Its magnitude during a brief planetary flyby is completely negligible and could not possibly generate the sudden, sharp velocity changes recorded by the tracking stations. Next, scientists explored the potential influence of Earth's magnetic field, reasoning that if the spacecraft had accumulated a net electrical charge during its journey through space, the planet's magnetosphere could exert a subtle Lorentz force on the moving vehicle. But when engineers calculated the maximum possible charge a spacecraft could hold, they found that the resulting magnetic push would be thousands of times too small to match the real-world data points. They even went so far as to analyse the gravitational pull of the Moon and the distant planets, the structural deformation of Earth due to tidal forces, and the subtle relativistic effects caused by the planet's rotation stretching the fabric of space-time, a concept known as frame dragging. Yet, even when every single one of these complex environmental factors was added together into the most advanced computer simulation models available, the calculated trajectory still failed to match the actual path of the spacecraft, leaving a persistent, unexplained gap in velocity. Because every single known conventional force failed to explain the mystery, a number of theoretical physicists began to contemplate a much more radical and exciting possibility that our fundamental understanding of gravity itself might be incomplete or flawed. For over a century, Einstein's general relativity has served as our absolute gold standard framework for describing gravity, passing every single experimental test with flying colours. But general relativity is primarily tested on either very small scales in laboratory environments or on truly massive scales involving whole planets and stars. A planetary flyby occupies a very specific middle ground, involving high speeds and unique hyperbolic trajectories that are difficult to replicate in an earthly lab. Some researchers suggested that the flyby anomaly could be our very first hint of new physics, pointing toward a subtle modification of gravitational laws at specific distances and velocities, an idea that could completely revolutionize our understanding of the universe. One of the most prominent alternative physics theories brought forward to explain the anomaly is known as modified Newtonian dynamics, or MOND for short. While MOND was originally developed to explain the unusual rotation speeds of distant galaxies without relying on the existence of invisible dark matter, some scientists believe that a variation of this theory could apply to local gravitational interactions within our solar system. The theory suggests that when an object experiences extremely low levels of acceleration, such as a spacecraft coasting through the outer edges of a planetary gravity well, the standard laws of inertia and gravity begin to change slightly, causing the object to behave differently than expected. If this hypothesis turns out to be correct, it would mean that gravity does not behave as a perfectly uniform force across all scales, and we would have to rewrite our physics textbooks to accommodate a more complex, multi-layered understanding of how matter interacts across space. Alternatively, some scientists suspect that the anomaly might be linked to a phenomenon known as dark matter clumpiness. We know that dark matter makes up the vast majority of the mass in the universe, forming a massive, invisible structural skeleton that holds galaxies together, but its exact distribution within our local solar system remains largely unknown. If dark matter does not just float around as a smooth, uniform mist, but instead forms dense, microscopic halos or clumps around massive bodies like Earth, a spacecraft passing directly through one of these hidden clumps would experience a brief, sudden gravitational tug. This extra mass would perfectly account for the spontaneous speed increase recorded during flyby maneuvers. However, because dark matter does not interact with light or conventional matter in any visible way, proving the existence of these local clumps is an incredibly difficult experimental challenge that requires highly sensitive detectors that we have yet to build. The ongoing debate surrounding the flyby anomaly perfectly illustrates the core nature of the scientific method, where even the smallest, most insignificant discrepancy in data can lead to profound questions about our understanding of reality. To get to the bottom of this mystery once and for all, space agencies are currently designing dedicated satellite missions whose sole purpose is to measure gravitational forces with unprecedented precision. One such proposed project is a specialized satellite mission known as STEP, or the Satellite Test of the Equivalence Principle. By placing an incredibly sensitive instrument into a perfectly stable orbit around Earth, completely isolated from any atmospheric drag or solar radiation, scientists hope to map the planet's gravitational field with absolute accuracy. This will allow them to determine whether the flyby anomaly is caused by an undiscovered environmental factor, a hidden pocket of dark matter, or a fundamental flaw in our current theories of gravity. As we continue to grapple with these local gravitational puzzles, we are simultaneously forced to confront much larger, more sweeping mysteries that dominate the outer edges of our universe. When astronomers train their powerful telescopes on the most distant galaxies, they discover that everything we can see, touch, and interact with, every single star, planet, gas cloud, and living organism, makes up a mere 5% of the total mass and energy in the cosmos. The remaining 95% of the universe is composed of two completely invisible, mysterious entities known as dark matter and dark energy. These unseen forces act as the ultimate puppet master of the cosmos, silently controlling the birth of stars, the movement of galaxies, and the ultimate fate of space and time itself. Yet their true nature remains almost entirely unknown to modern science. Dark matter was first hinted at back in the 1930s, when the Swiss astronomer Fritz Zwicky was studying the movement of galaxies inside a massive cosmic structural group known as the Coma cluster. When Zwicky calculated the total mass of the cluster, based on the visible light emitted by its member galaxies, he discovered that there was nowhere near enough normal matter to generate the gravity required to hold the cluster together. According to the laws of standard physics, the galaxies were moving so incredibly fast that they should have flown apart into deep space long ago, ripping the entire cluster to pieces. Zwicky concluded that there must be a massive amount of invisible, hidden mass providing the extra gravitational glue needed to hold the system together, a hidden substance that he labelled as dunkle materie, or dark matter. For decades, Zwicky's radical ideas were largely ignored by the mainstream scientific community, who viewed his observations as a temporary anomaly that would eventually be explained away by more accurate telescopes. However, in the 1970s, a brilliant American astronomer named Vera Rubin provided definitive, undeniable proof that dark matter was a real, universal component of the cosmos. Rubin was meticulously measuring the rotation speeds of individual spiral galaxies, expecting to find that stars located at the outer edges of a galaxy would move much slower than stars clustered near the dense, bright centre, a pattern that perfectly mirrors how the outer planets in our solar system orbit the Sun much slower than the inner planets. Instead, to her absolute amazement, Rubin discovered that stars at the outer rim of a galaxy were moving at the exact same high speed as the stars near the core, behaving as if the galaxy was embedded inside a giant, invisible sphere of massive matter that distributed gravitational forces evenly across the entire structure. Today, scientists understand that dark matter forms a massive, invisible cosmic web that spans across the entire universe, acting as the fundamental structural framework around which all normal matter gathers to form stars and galaxies. Without the immense gravitational pull of dark matter, the normal gas and dust in the early universe would have never been able to pull itself together tightly enough to ignite the very first stars or build the beautiful spiral galaxies that we see today. Yet, despite its overwhelming presence and crucial role in cosmic history, dark matter remains completely invisible to our telescopes because it does not absorb, reflect, or emit light in any way. We can only detect its physical presence indirectly by observing how its immense gravity bends the travelling light of distant stars, a fascinating phenomenon known as gravitational lensing. While dark matter acts as an attractive gravitational glue that tries to pull the universe together, its mysterious counterpart, dark energy, behaves in the exact opposite manner, acting as a repulsive force that is actively tearing the cosmos apart at an accelerating rate. The discovery of dark energy in the late 1990s completely shattered our fundamental assumptions about the future of the cosmos. Before this discovery, most cosmologists believed that the overall expansion of the universe, which was originally uncovered by Edwin Hubble, would slowly decelerate over time due to the relentless gravitational pull of all the matter in space. It was assumed that the universe would either eventually come to a complete halt or reverse direction entirely, collapsing back inward in a catastrophic event known as the Big Crunch. To measure this expected deceleration, two independent teams of astronomers set out to study a very specific type of stellar explosion known as a Type 1a supernova, because these specific supernova always explode with the exact same intrinsic brightness. They function as perfect cosmic yardsticks, allowing scientists to calculate exactly how far away a distant galaxy is by measuring how dim its supernova appears from Earth. By comparing the distances of these supernovae with their structural redshift values, the researchers hoped to calculate the precise rate at which gravity was slowing down the expansion of space. But when the data finally came in, it revealed something that left the entire scientific community in absolute disbelief. Distant galaxies were not slowing down at all. In fact, they were rushing away from us faster and faster with every passing second. proving that the expansion of the universe is actively speeding up. To explain this mind-boggling discovery, physicists had to introduce a brand new concept to our cosmological models, a mysterious anti-gravitational energy source that permeates the entire fabric of space, which they named dark energy. While dark matter makes up roughly 27% of the universe, dark energy accounts for a staggering 68%, completely dominating the cosmic energy budget. Unlike normal matter or dark matter, which become less dense as the universe expands and grows larger, dark energy appears to be an intrinsic property of space itself, meaning that as new space is created through expansion, the amount of dark energy grows along with it. This creates a relentless, self-reinforcing loop where the expansion creates more dark energy, which then forces the expansion to speed up even faster, driving the universe toward an increasingly rapid and unstoppable separation. The true nature of dark energy remains the single greatest problem in all of theoretical physics, creating a massive conceptual chasm between our understanding of large-scale cosmology and small-scale quantum mechanics. When quantum physicists attempt to calculate the natural energy density of empty space based on the behaviour of subatomic virtual particles popping in and out of existence, they arrive at a number that is a staggering 120 orders of magnitude larger than the real-world value of dark energy observed by astronomers. This colossal discrepancy is widely considered the worst theoretical prediction in the entire history of science, highlighting a profound flaw in our current understanding of how quantum forces interact with the large-scale structure of space-time. Until we find a way to unify general relativity with quantum mechanics into a single, comprehensive theory of quantum gravity, the true identity of dark energy will likely remain completely out of our reach. Because of the massive scale of these unresolved cosmic parameters, cosmologists are pushed to imagine the ultimate destiny of our reality, the interaction between dark matter trying to collect structural groups and dark energy attempting to tear them apart, will decide the final chapters of our universe. If dark energy keeps dominating the expansion profile as it does right now, the universe faces a long, slow cooling down process that scientists call the Big Freeze. Over trillions of years, galaxies will drift so incredibly far apart that they will become completely isolated from one another in the expanding void. The raw gas clouds inside these independent star systems will eventually be totally used up, leaving no materials to ignite new stars. One by one, the existing stars will consume their remaining nuclear fuel, fade away into cold stellar remnants, and go completely dark. The entire universe will turn into a cold, dark graveyard of black holes and dead stellar embers, stretching across an unimaginable emptiness, where temperature drops to absolute zero and all thermodynamic processes stop forever. Alternatively, if the strength of dark energy grows exponentially over time, it could trigger an even more violent and catastrophic end scenario known as the Big Rip. In this terrifying scenario, the repulsive force of dark energy becomes so intensely powerful that it completely overpowers all other fundamental forces of nature. First, it will easily tear apart massive galaxy clusters, followed by pulling individual galaxies away from their structural orbits. As the acceleration reaches its peak, planets will be violently stripped away from their host stars, and the stars themselves will explode into scattered particles. In the absolute final moments of this cosmic tragedy, the literal atomic bonds holding matter together will be forcefully ripped apart, breaking down molecules, atoms, and subatomic particles into nothingness. Even the fundamental fabric of space-time itself will be torn to shreds, leaving behind an empty, featureless void where no physical structures can ever exist again. On the completely opposite end of the spectrum, there is a possibility that dark energy could eventually lose its strength or reverse its direction over time, allowing gravity to reclaim its role as the dominant force in the cosmos. If this reversal takes place, the expansion of the universe will slowly grind to a complete halt and begin moving backward, causing all distant galaxies to rush toward one another. This reverse movement is known as the Big Crunch. As the universe shrinks in size, galaxies will collide and merge at high speeds, and the ambient temperature of the cosmos will skyrocket to extreme levels. The background radiation will become hotter than the surfaces of stars, filling space with a blinding, lethal glare. In the final phases of this collapse, all matter, stars, planets, and black holes will be tightly compressed into a single, infinitely dense and unimaginably hot point, mirroring the exact conditions of the initial Big Bang and completely erasing the history of our universe. Some theoretical physicists take the Big Crunch idea a step further by suggesting that this compression point might not be the absolute end of existence, but rather a transition phase into a brand new beginning. They propose that when the universe collapses into an extremely dense state, the extreme pressure could trigger a brand new expansion event, a concept known as the Big Bounce. This framework implies that our universe is part of an infinite, eternal cycle of cosmic rebirth, moving through a continuous loop of expansion, contraction, bounce, and re-expansion. Every single cosmic cycle would produce entirely new arrangements of stars, galaxies, and potentially new forms of life, meaning that our current universe is merely a single link in an endless chain of cosmic iterations that has been repeating for eternity without a beginning or an end. To study these immense cosmic possibilities and test the true boundaries of our gravitational theories, space agencies are working hard to launch advanced satellite experiments. One of the most promising initiatives is the Specialized STEP project, which stands for the Satellite Test of the Equivalence Principle. By placing an incredibly precise high-tech instrument into a perfectly stable orbit around Earth, scientists can isolate the experiment from the disruptive noise of atmospheric drag, seismic vibrations, and solar radiation pressure. Inside this ultra-quiet orbital environment, the spacecraft will have the complete freedom to observe, measure, and analyze the subtle behavior of gravitational forces with an exceptional level of sensitivity that is entirely impossible to achieve in a laboratory on Earth. The advanced equipment on board the STEP satellite is designed to detect both the subtle gravitational forces exerted by the Earth and the immense pull of the Sun to an astonishing mathematical accuracy of 10 to the minus 17th power. This extreme sensitivity will allow scientists to test the equivalence principle, the foundational pillar of Einstein's general relativity, which states that all objects fall at the exact same rate regardless of their mass or composition, with unprecedented precision. If the experiment uncovers even the tiniest variation in how different materials fall through space, it will expose a fundamental flaw in general relativity, opening the door to a brand new era of quantum physics and changing our comprehension of gravity forever. Furthermore, the STEP spacecraft will follow a carefully calculated orbit that deliberately takes it through the various distances and coordinates at which anomalies were previously observed during historic planetary flybys. If an undiscovered property of gravity or a hidden local mass distribution is indeed the root cause of these strange speed variations, the satellite's sensors should be able to precisely demonstrate how the magnitude of the effect changes with distance from Earth. This real-time orbital mapping will provide engineers with a clean, comprehensive dataset that can isolate the anomaly from any external tracking errors. Thus, while STEP's primary focus is on advancing our deep understanding of fundamental gravity, it also holds the unique potential to finally unlock the long-standing secrets of the flyby anomaly that has puzzled aerospace engineers for decades. Throughout the entire course of human history, our species has managed to build an absolutely incredible, breathtaking body of knowledge about the vast universe surrounding us. We have progressed from primitive stargazers mapping constellations with the naked eye to advanced civilizations launching robotic telescopes into deep space, capturing the remnant light of the early cosmos and tracking down thousands of foreign planets. We have split the atom, decoded the laws of orbital mechanics, and developed highly complex mathematical equations to describe the history of space-time. Yet, when we measure our collective achievements against the sheer, unmeasurable scale of the cosmos, it becomes screamingly obvious that we are only at the very beginning of this grand journey of discovery. The universe remains a beautiful twilight realm of enigmatic secrets, completely replete with unexplained mysteries, deep paradoxes, and hidden dimensions that are shaped by unseen cosmic forces. It behaves exactly like a giant, infinite jigsaw puzzle, made up of an uncountable number of delicate pieces. But our current technological and physical limitations allow us to see only a small, microscopic part of the full picture. Every single breakthrough we achieve and every single answer we uncover invariably brings along a dozen brand new questions, reminding us of our fragile position in the grand architecture of space. This continuous mystery is not a sign of failure, but rather the ultimate driving force that keeps pushing humanity forward, inspiring us to build better tools, think deeper, and keep looking up at the dark void with an everlasting sense of wonder and curiosity.